Hello guys, welcome again to my channel. I want to solve this nice polynomial equation which read x squared minus x cubed is equals to 12. Then we are looking for all the possible value for x. So if you are new here, kindly subscribe to this channel and please don't forget to smash on the notification button so that you get notified whenever I drop videos on mathematics. So let's see how we can provide a solution to this equation which reads x squared minus x cubed is equals to 12. So if we want to solve this, I can simply say solution. Okay, we can write a question which is x squared minus x cubed equals to 12. Okay, the first thing I can do again, the next thing I can do again is to bring the whole of this 12 to this left hand side of the equation. So if I should do that, I'm having x squared minus x cubed minus 12 equals to 0. Okay, so what then is the next step? Okay, I can rewrite my 12 minus 12 is equals to minus 4 minus 8. Okay, so in the place of minus 12, I can put minus 4 minus 8. So I'm having this to be x squared minus x cubed minus 4 minus 8 equals to 0. Okay, this is what I'm not having. So having done this, I can raise 4 to the power of 2, which is 4. It's also equals to 2 to the power of 2, and 8 is equals to 2 to the power of 3. Okay, so wherever I see 4, I'm putting 2 to the power of 2, and wherever I see 8, I'm putting 2 to the power of 3. So which implies I'm having x squared minus x cubed minus 4, which is 2 to the power of 2 minus 2 to the power of 3 equals to 0. Okay, so to simplify this, we are having 2 to the power of 2 and 2 to the power of 3. We're having x cubed here and we're having x squared here. Let this come this way and this come this way. So if I should do that, I'm having x squared minus 2 squared minus x cubed minus 2 cubed equals to 0. Okay, so this is what I'm not having. Okay, having done this, I can simply put a bracket here. Okay, then put a bracket here. So I can put bracket x squared minus 2 to the power of 2 or into the bracket minus x cubed minus 2 cubed equals to 0. Okay, we cannot see that there is something common between two of them, which is the negative sign, right? So if we should factor out the negative sign, we simply have this to open bracket x squared minus 2 squared minus close the bracket minus open bracket x cubed plus, right, 2 cubed close bracket equals to 0. Nothing changes, it still remains the same. So having done this, what are we simply going to do? Okay, this is a difference of this, which we can write. If you're having a squared minus b squared, it's also equals to a plus b times a minus b. So we're having a squared minus b squared is also equals to a plus b times a minus b. So this we can compare with the whole of this. And if we are having a cube plus b cube is equals to a plus b into a square minus ab plus b square. So a cube plus b cube is equals to a plus b times a square minus ab plus b cube. Sorry, plus b square. Okay, so if we should put the whole of this into this, we can write the whole of the equation to be this. So x squared minus 2 squared can be written as x plus 2 times x minus 2 minus, and x cubed plus 2 cubed can be written as open bracket x plus 2 times x squared minus 2x plus 2 squared. Okay, so this is what we are now having. So having done this, we can have this to be x plus 2 into x minus 2 minus open bracket x plus 2 into x squared minus 2x. So 2 squared is going to give us plus 4. Close the bracket. Okay, we can now see we're having x plus 2 here, we're having x plus 2 here. They are common factor. Recall, everything is all equals to 0, equals to 0. We're having x plus 2 here, we're having x plus 2 here, so we can easily factor them out. So if we factor them out, we have this to be open bracket x plus 2 close bracket into x minus 2 minus open bracket x squared minus 2x plus 4 close bracket or close the big bracket equals to 0. Okay, this we can equate it to be 0, so we can have x plus 2 equals to 0, right? Then we are having this. If you open this bracket, right? If you open this bracket, so we have this to be x minus 2. So open this bracket with the negative sign. We are going to have x squared plus 2x minus 4 close bracket equals to 0, right? Okay, so if we are comparing this to be equals to 0, we can say x is equals to minus 2. So we can call this one x1. So if we should take like terms here, we take like terms. We are having x here, we are having 2x here. X plus 2x is going to give us 3x. So we can say minus x squared plus 3x. Minus 2 minus 4 is going to give us minus 6 equals to 0. Okay, if you bring everything, the whole of this, to the right hand side of the equation, we have this to be x squared minus 3x plus 6 equals to 0. Okay, having done this, what are we simply going to do again? So we've gotten the first value of x, which is x1 is equals to minus 2. So we want to get the second and third value for x. So with this, we can apply the formula method, which say our x is equals to minus b plus or minus into the root of b squared minus 4ac over 2a. Okay, where our b is equals to minus 3, our a is equals to 1, and our c is equals to 6. So if you substitute everything into this equation, we are going to have our second and third value for x. So let's solve further. Okay, since we are not having this, the formula which is x is equals to minus b plus minus root of b squared minus 4ac over 2a. Then we said our a is equals to 1, our b is equals to minus 3, our c is equals to 6. So let's substitute all these values into this equation and solve out for the remaining two values of x. So we can say x, which is equals to, so minus, open bracket, minus 3, close bracket, plus or minus the root. What is your b? So we can say minus 3 all square minus 4 times 1 times 3, right? No, times 6 rather. Times 6, because c is equals to 6. We're having 6 here over 2 times 1. Okay, so having done this, so we can say our x is equals to minus is going to turn to plus 3 plus or minus the root of this is going to give us 9. We're having 9 minus 4 times 1 is going to give us 4. 4 times 6 is going to give us 24 over 2. Okay, so we are not having this, so 9 minus 24, so we have this to be x is equals to 3 plus or minus the root of 9 minus 24 is going to give us minus 15. Okay, minus 15 over 2. So this is what we are now having. So we are now having a negative sign here, and a negative sign does not have a square root, but we can simplify this further by applying the complex rules. So before we do that, we are going to apply a simple surd rule, which says the square root of a times b is equals to the square root of a times square root of b. Okay, so if we should put this principle here, we can say our negative 15 is equals to negative 1 times 15. Okay, so we can write x equals to 3 plus or minus the root of negative 1 times 15, okay, over 2. So this is what we are now having. And we said the square root of a times b is also equal to the square root of a times square root of b. So if we should put this principle here, we have this. We have our x is equals to 3 plus or minus the square root of minus 1 times the square root of 15, okay, over 2. Okay, and the square root of minus 1 is equals to I, which means your imaginary value. So we can say x is equals to 3 plus or minus, so wherever we see square root of negative 1, we are putting I times the square root of 15. Okay, square root of 15 divided by 2. So we can see we are having a plus and negative, therefore our x2 is equals to 3 plus, so we are putting I root of 15 divided by 2, and our x3 is equals to 3 minus I root of 15 divided by 2. So these are the values for x2 and x3. And recall we said our x1 is equals to negative 2. Therefore, x1 equals to negative 2, okay, comma x2 is equals to 3 plus I root of 15 divided by 2, okay, our x3 equals to 3 minus I root of 15 divided by 2. So these are the values for x1, x2, and x3. So if you find this video useful and interesting, please click on the subscription button if you have not done that, and also turn on the notification bell. Bye bye. Please don't forget to hit on the thumbs up button. God bless you, Jesus loves you, and see you in my subsequent videos for further maths. Bye bye.